Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat. But before we begin, I'd like to quickly review two items: our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our channel. And if you have not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Bringing us to today's session. Today is week 4 of the season of AI for developers. I'm going to bring in our speaker here, Luis and Pablito. Hello, welcome back.
Hi, Alexia. How are you? Pablito, how are you doing?
Great.
Hey. Hi, Alexia. Hi, Luis. Hello, everyone. Well, Pablo Pivano here from Argentina.
And Luis Beltran from Mexico. Thank you for being here. We are really happy. We are really excited for this next session. Pablito, can you give us some kind of overview what we are going to learn today?
Today we are on episode number 4, weeks 4 of 5 of on this part we have already learned basic concepts to make sure everyone is aligned. Then in episode number 2 we learned how to manage Azure OpenAI service quota, understand the trade-off between performance and latency, plan costs, manage them, and the important to apply the RAG pattern to our developers deployment. And in the previous episode, we will discuss the latest from Microsoft Build. By free GPT-4 Omni models with multimodal capabilities, the new Azure AI Studio portal to start creating our generative AI development and another topics that I don't remember now. And in these 2 final episodes, we will learn about semantic kernel, and the last episode we learn how to build our copilot. Wow.
Yes, we are going to learn about some people call it framework, some others SDK, library. What do you think in the chat? Well, in the end, this is a tool that can help you build AI agents easily. Let's say you don't have to worry on the implementation of some API, prepare parameters, follow let's say strict rules of the OpenAI or Azure OpenAI SDK. Instead, you can very quickly plug in with your data, with your code. That I think that's the relevant part here, that maybe you have an application, you want to infuse AI on it, so you can do it. And you will see, for example, maybe you already have some methods, some functions, how we can integrate these into, let's say, the AI technology, so it can be used by OpenAI or LLM models in general. The idea of semantic kernel is that you can integrate your code with AI. And we will see, we will start from basics, what we have to do, what library we have to add, what are the components, right? So a bit of theory, maybe in the first 15 minutes, then full demo. And of course, we will also explain some concepts. Awesome. So let's get started. Thank you, everyone, for your comments in the chat. We see some people from Colombia, France, US, Mexico. So thank you, everyone, for joining us around the world. All right, so let's get started with semantic kernel. What is semantic kernel? Well, sorry. In order to help developers build, as Pablito said, their own Copilot experiences on top of AI plugins, there is an open source SDK, a lightweight open source SDK known as Semantic Kernel. This one allows you to orchestrate plugins, and with plugins, we refer to our code, our functions, our methods with AI. One key concept or feature about semantic kernel is that you can take advantage of the same orchestration pattern that powers Microsoft's Copilot experiences in your own applications. You know that there is GitHub Copilot, Microsoft Copilot, and there are others, right? There is another one for Teams, I believe, for chat, Bing chat. In the end, you have, or the user has a need. Maybe they want to ask a question. They want to use AI for some task like summarization, or maybe find relevant information, providing some context, some background information, some text. They want to solve some issue by using these chat GPT-like experiences. So with semantic kernel, you can do it. And the idea is that you focus on solving that issue, and everything, let's say, regarding the communication with the LLM is encapsulated by semantic kernel. You will see, right, how we're going to prepare our code to be ready so we can build these agent experiences, and we can focus on solving tasks. Pablito, anything you would like to add here?
Yeah, yes. Only I will add that semantic kernel will help us integrate the world of artificial intelligence and application developers. These two words, which should be working hand in hand as one team, often operate in separate silos. Why? Because they use different tools. AI research are looking into the future, testing the last model and strategy. Meanwhile, enterprise app developers are ensuring that services are secure, reliable, build customer trust. These are two different skill sets that should be working together, but today we don't, and the main reason is the mismatch in the tools they use. AI research predominantly work with Python, while app developer use .NET or Java. And Python developer, when they are finally ready to release an application, face the challenge of maintaining it live, something they haven't done before. On the other hand, enterprise app developers sometimes feel slighted in sure of how to handle all this AI stuff as well as their counterparts. We need a bridge that allow both to collaborate without having to learn a whole new set of skills. That bridge at Microsoft is semantic kernel. We are already at version 1.56, depend the SDK in Python and .NET and Java. This means that starting today, you can build something and be confident that you won't have to redo everything in a year or two. Additionally, if you use this SDK across your different teams, you can align on key concepts like what an agent or a plugin is. This way, you can focus on what really matters, building things for your customer. Most importantly, each of the version 1 has the same inputs and outputs. This means that if you have a prompt or a plugin, it will work the same way, no matter the technology you use. With this, AI developers can keep doing what they do best, building proof of concept, figuring out what is coming next, and ensuring that their company remains relevant. And when they are ready to move to production, they won't have to worry about developing app or frustrate their fellow developer by asking them to refactor everything from scratch. They will simply hand over the asset ready to be used.
Awesome. Thank you, Pablito. I think you said a really important thing here is that you can connect to different providers. We will mention them in some slides. So again, the developer maybe, or maybe you are in a team, right? It doesn't matter which technology you are using behind, like Azure OpenAI, or some models from Hugging Face. You can very quickly switch from one provider to another one for proof of concept, for production applications. And let's say that the workflow of your application is not affected. And the idea is that you can maybe evaluate the different responses from these different providers in order to choose the one that suits you best, right? So, well, we will learn how we can do this, especially next week. I mean, on Monday, when we had this session in Spanish, someone asked if we could do some example about testing. And yeah, I'm preparing some demos. So next week we will do some unit testing with semantic kernel. The idea is that we will evaluate, let's say, outputs from different LLMs in order to, for example, check truthfulness, right? It also fits in the responsible AI part. So yeah, just come here next week for that demo. Okay, so for like a general overview, well, something just to summarize. Okay, we already mentioned that this is an open source SDK. Yes, it is true that people from Microsoft is behind this plugin, and even there is documentation on the Microsoft website. However, it is also true that there is a lot of community support behind this library, and there are several contributions by developers, right? So this is really nice because we can see how the technology is implemented. If we find some bug, well, there are some issues on GitHub, or we can follow up for updates. Yes, so we can also focus on the integration of different AI models. It could be different versions. Let's say we can very quickly switch from, I don't know, GPT 3.5 Turbo to GPT-4, or we can switch from different providers, right? Azure OpenAI, and others. The idea, again, is that we can build very quickly AI agents, and we can integrate our code on using this, let's say, AI technology. Semantic kernel is designed to be flexible, that we can not only build console applications, even though we will focus, right, on console applications for a quick start, But definitely, you can create mobile applications, maybe with .NET MAUI, web APIs or front ends, right, using Blazor, ASP.NET Core. So it is compatible with these technologies. So in the end, you will create a robust application using .NET. It supports C# and Python mainly. However, there is also some preview support for Java. Mainly here, contributions from community will be relevant. But yes, Java is supported as well. And as we mentioned, there is a robust community support with tutorials, forums, resources for developers to collaborate and enhance their AI projects. Okay, so in general, everything using semantic kernel starts with some question, maybe some task, some instruction that some problem that we want to solve. Right? So all the complicated LLM stuff, like prompts, like the parameters, like temperature or top P, the different arguments that LLM models need, is encapsulated by semantic kernel SDK. We can, of course, define or pass some arguments in order to work with them, right? But let's say that they are kind of optional. The kernel is the most important part. It orchestrates the task, the question, whatever the user needs, to something called planner. The planner builds some steps that are needed in order to solve the initial task or the initial problem. Don't forget that you have your code. You will have different functions. Some of them, and we will mention this later when we talk about plugins, we will add some attribute. We will mark them with let's say some attributes. So the AI, or sorry, the planner knows that it can use these methods or these skills in order to solve the task. Since there will be a lot of methods, the AI will be smart enough to choose which function or functions, because it can be more than one, is needed to solve the initial task and the order in which this should be executed. If you have worked with the Azure OpenAI, with OpenAI models, well, you probably know about some feature known as function calling. Well, yeah, I think that's the key part. It uses function calling in the back in order to determine the steps and the right functions that will be called. However, also, if you have implemented function calling, you know that it is not easy to build some pipeline or to determine the steps. You always need to check if there is another step, or if there is some parameter that we need to pass, right? And it can also be kind of expensive in token usage. So this planner is optimized to minimize, right, the steps, but of course get a high quality level answer, right, or to solve, let's say, the initial task. By the way, if you have worked with LangChain or you know about LangChain, semantic kernel is basically the same, but for C# and also Python Word. Okay, so this is kind of the same. In the end, the idea is that you, as a developer, focus on the task and achieving some goal, right? Something that we will talk next week is that all this pipeline also includes powerful technologies such as memories and connectors. Connectors, let's say, for real-time information, maybe from some API, or also the embeddings in order to extend the knowledge from the base knowledge from the LLMs. You know, basically with memories, we will talk about embeddings, about RAG, which we already mentioned in previous sessions, but how we can integrate this into semantic kernel, right? In order to get, let's say, new productivity or achieve new productivity and also some result, right? To reach a goal. That's the idea. And well, this is just a summary. There are a lot of components, there are a lot of elements that we can connect or include in semantic kernel. Not all of them are required, mandatory. Some of them are optional, but of course, adding them supports, let's say, our goals or can help us to achieve the results with, let's say, with something that we want to achieve closer to the expected results, let's say, okay? So there will be some AI services, different connectors from Azure OpenAI, Hugging Face. We can also add enterprise components such as logs, monitor, telemetry, right? Maybe we want to monitor the token usage. And actually next week, I will talk about some library that you can use to connect or to know how many tokens every request is using, right? We prepare some kernel, and we can connect memory, external functions, our own functions or native code, create prompts, and also optimize the planner, right? The planner that we mentioned later. In the end, you invoke. Invoke, let's say, it's an important method because that means that you want the AI to do something, right? And the invoke method is, okay, now it's up to the AI to solve the initial task. Again, we don't have to add all this, but this is like a brief overview of what you can add, what you can connect for semantic kernel applications, right? And we are close to our first demo, just maybe 2-3 concepts. So the kernel is the most important part. This is the core, the center, the essence of an object or a system that is really important. Semantic kernel creators said that they built this technology around the kernel, and they found, or let's say they got inspiration from the Unix kernel. And you know, or maybe you have heard, that this kernel is small but fully extensible. So and yeah, this let's say behavior is resembled in how semantic kernel works, because as I mentioned in the previous slide, we can connect, we can add different components optionally, like memories or external or native code, right? Or semantic functions, yes. So the idea is that the kernel is essential, and there we will connect, we will glue different components. And of course, it is semantic because it uses AI models. So the main element is the language, right? There is a task, and maybe the input comes from our voice or from text or different sources. And usually, yes, the output will be some other text. Although, because some LLMs are able to generate images, that is also possible. Actually, our last demo for today's session is about image generation. Okay, so now we are ready to some code. So this is how we are going to start. First of all, we need to add the Microsoft.semantic kernel plugin, NuGet package, sorry, NuGet package in our application. It doesn't matter if it is console, web API, .NET MAUI, it is supported. Then we add or import some namespaces, mainly Microsoft.semantic kernel, and there will be others. Well, and if you have worked with backend with web APIs, you might find this code kind of familiar, right? So we create a builder from the kernel base class, and in the builder, we add, for example, or connect to different technologies. In this case, add Azure OpenAI chat completion. We can register other services like image generation, OpenAI chat completion, so not from Azure, but OpenAI, and different providers, different services. Once we registered all of them, and this actually uses how is it called? Let's say injection, right? Techniques. You can build. You can prepare. You already prepared your builder. Now you can get a kernel, and this is the object that we are going to use mainly in the rest of our code. As you can see here in the OpenAI chat completion method, we include the different arguments that, well, probably you already know, right? Such as an endpoint, an API key from your resource, in this case, an Azure OpenAI resource. Of course, you need a model deployed, so you need the name of that deployment, and optionally, you can provide a model ID, right? If you want, but the most important part is the deployment name. And once you prepare this, we can add prompts, right? Of course, as we mentioned earlier, the prompts are relevant because that's how we are going to let's say, affect the behavior of the AI model, and also we are going to instruct what they should do or what we want them to do. Of course, you already know that there are different prompts: system prompt, user prompt, also meta prompts. This will be relevant in plugins, more on that later. And the prompt is also known as a semantic function. So if you are reading the documentation and sometimes you find this semantic function, essentially they are talking about prompts, okay? And this is how you are going to provide a prompt. And actually, this is like the task, right? So we are using the invoke prompt async method from our kernel, and it accepts, of course, a string, right? Let's say, give me a list of breakfast foods with eggs and cheese. This method is awaitable, so then you use this result for whatever purpose you want. You can print it, you can save it to a database, or you can use it for another task. You can analyze it, up to you, right? And well, we can explain this later, but basically here we have different endpoints from Azure OpenAI, Hugging Face, or even our local ones, right? Yes, they are also available. Probably this image is not updated, but essentially you see that there is support in different languages from these different endpoints. And of course, services like text generation, text embeddings, image generation, right? So let's talk about our first demo. And I will share after this first demo, the GitHub repository where you can find this code, okay? So just give me maybe 5 minutes and I will do it. Okay, so of course, the first part is that this application already has the Microsoft.semantic kernel plugin installed, right? Okay, so here we have it. Now, okay, I think you can see it. If not, let me know and I will increase the font size. Well, so as you can see, well, we have some deployment, model, endpoint, and key, the information that I already mentioned to you. We prepare our builder, we add this endpoint and service, Azure OpenAI chat completion. Don't worry about this one. I will add it later for another demo. And we build in order to get a kernel that we can use in our, let's say, tasks. So this is the first task, okay? Maybe we prepare some prompt, give me a list of 10 cool short names for a software development company. And we use the invoke prompt async method, just as I explained in the previous slides. Then we will see some result, okay? Just give me a second and let's run it so you can see the result. And now I will explain some other examples later, right? So you can see that essentially we prepare. It's kind of similar, right? What we do when we are using Azure OpenAI SDK, but we are not focusing, or the most important part is not the implementation, right? Okay, I'm sorry for that. Probably not sure if I deleted it. I will check this. Yeah, I think I deleted this endpoint. So, okay, sorry for that. I will very quickly switch, or I will provide some other endpoint. Just give me a second, right? Okay, yes, because this endpoint no longer exists. So I'm sorry for that. Before I explain that. So the idea is that, yes, we focus on the prompt, on the task, in order to, let's say, build this agent. So we are not worrying about invoking some backend or how we prepare the different arguments from Azure OpenAI SDK, right? This is like very, very simple. We provide these arguments, then we focus on the task, and that will be true for the next, let's say, for the next part. Before I, let's say, fix this, again, sorry for that, I mentioned that we can also include some arguments from the different LLMs. So here in this case, you can see that we have, we can prepare an OpenAI prompt execution settings in case that we want to specify the max tokens, also the temperature. So we can provide these settings as a second parameter in the invoke prompt async method. We have a different task here, like write a summary about Olympic Games. And you know that LLMs, they want to talk, they want to say a lot of things. So if we give this task, you know that a lot of text will be generated. But because for this second example, we are limiting the output, only the first 100 tokens will be returned, right? But we are using the same method. And for the third example, well, in both cases, for the invoke prompt async, we need to wait until the answer is generated, so we get the full output. However, if we want to simulate or emulate the behavior of a chat application, we can use this second method, invoke prompt streaming async. This method basically returns chunks of the output like a stream, right? So you will get partial results as they are being generated. But in order to retrieve this, and actually they are not tokens, let's call it chunk actually. In order to get these chunks, we need an awaitable for each, right? So this would be the only difference, right? This method is not awaitable at all, but in order to get the output, we do need the async and await pattern, right? So yeah, and of course here I am printing it, but I can do something different, right? Again, storing to a database, or yeah, so different tasks, okay? In the meantime, Pablito, are there any questions?
Luis,
Anything that you would like to?
I share with you the endpoint, the key,
Okay.
and the model
Okay.
name by WhatsApp,
Okay.
and you can use
Thank
it.
you very much. So just give me a second. I will focus. I will
Yes.
fix that. Yes. Thank you very much. Okay. Well, I don't have WhatsApp at all. I
Okay,
mean,
okay. Let me share with
yes, in the internet chat,
the
please.
yes. Let me
In the meantime, I can fix the
share.
simpler term. Okay, so this is fine. This is fine, and yeah.
Key.
Okay, thank you.
Yes. Sharing the chat.
Thank you. Thank you.
Perfect.
Okay, so let's test it now. I think the name is the same.
I hope have quota is available.
Yeah. Okay.
Yes.
So the first example is here: 10 cool short names for software development company. You see it. Perfect. Nice. So second example, we will get the summary, of course, of the Olympics, but in 100 tokens, right? And the third example, be ready. You will see, okay, in the previous one, we got the full output, but now we will get in chunks. Okay, so be ready, 3, 2, 1. Okay, so you see it, part. Okay, so as if we were receiving or someone was writing this information, right? If we didn't do a stream, we will get, or we will see the final result, right? So this is the first part, very easy to connect. And well, I think we can move to different next part. Don't worry, I will answer some of the questions in the chat. Pablito, would you
Okay.
like to talk a bit about file and prompt templates?
Yeah, yes, perfect. Well, as we mentioned, we have seen that we can create a text string and pass the prompt as it. But we can also build what is called a template. This is this part of generating dynamic prompts where the information can vary or different wherever it's come from a file, an API is input by the user, etc. It's not just about variables. Functions are involved as well. For example, we can have a function that change of demand or under certain condition. And the same applies to arguments. So we can have a prompt as a text string with two elements. That we can change code expression such as a statement or a function call, which are placed inside in double brackets, and variables which are indicated with the dollar sign. These functions must be registered when loading the kernel. Um, let's look at a code example in real time so you can understand it better. Luis, next slide, please. Perfect.
This
Well,
one or
here, yeah, this. Here, you can see a rather large string that will be the context followed by a prompt. This is our template where we place a variable called history. Notice the double brackets and the dollar sign before its history. Everything else remain the same. Here we use invoke from async, and the argument are something we will explore later when we discuss plugins and functions. What I want you to show now is how you can include variables and expression in your prompts using this format of bracket and the dollar sign. This is important for it to be detectable in C#. Next slide. Thank you. Thank you. Well, you can also use text files to organize your prompts, which is useful if you have a collection of plugins or prompts that you want to reuse in different applications. For this, the prompt must be in a specific folder, such as a folder called prompt plugin, which we will discuss later as a concept similar to a class. Next slide, Luis, please. Well, each prompt must have two specific files, the config.json and skprompt.txt. The ski prompt file contains all the content of the prompt, instruction, output format, additional data, etc. If you want to add dynamisms, use the concept of a prompt template, where you place the variables in config JSON file. Well, in config JSON, we configure three elements: the execution settings, such as the maximum number of tokens and the temperature. A brief description of the prompt, so that the LLMs model can benefit from the metadata and the input variable of the prompt template, such as input and style. Next slide. Perfect. Well, to link everything together, you must include this file in the output directory when working with Visual Studio or Visual Code. Then prepare the kernel arguments. Place the key and value in the dictionary and use invoke async to execute a specific plugin, passing the different prompts and selecting the one you need. Well, let me show you. Let me share my screen here. Well, Alicia, could you switch to my screen? Well, we will share the repository with you, where you will find many examples, especially in C#. There are example notebook to get started with semantic kernel step by step, starting from the simple concept and moving forward more complexity. Well, here I have this notebook. Yes. In this part, we can import the plugins and the function. Here, I use different files. You can see, let me, in the repo, you can find this folder, prompts and play samples. And in this case, we will use phone plugin and the show. And here we have the two files that I mentioned, the config JSON and the ski prompt.txt. Here is the structure that is the same that we show in the slide. And here we have a prompt, and we give the personalizing that we creative and funny. You want to laugh. Well, and remember the dynamic variables. Well, let me switch to the code here. Let me run this. Here we construct the argument and pass time travel to dinosaur age. And this is a show. Why did the time travel rain or later to the dinosaur age? Because he heard the right Cyrus has the best high five. Well, it's a the same example that we show in the slide. Now let me switch to another code. Well, later Luis will explain it better, but in this example, um, we are going to use one of the plugins integrate into Semantic Kernel, which is the time plugin. However, we will also be able to create our own plugins or use the ones that are really integrated. Well, this code is part of a class that extend a base class called base demo. Let me find here. Okay. Well, this is the more important here that we will use. And the class, well, this class is named prom02 daytime, and it is proposed is to demonstrate how the semantic kernel, well, can be used with a plugin to work with days, dates, and times. Below, I will explain each part in a simple way. Well, inherit the base code. This method, the create kernel, is where an instance of the kernel is configured and created. The kernel dot create builder use it to build the kernel, and the ability to use the Azure OpenAI services is added to utilize the GPT model. Finally, applying called time plugin is added, and the kernel is built with builder dot build. Well, we have another method. The method create plugin async. This method create a list of plugins or station that the kernel can use. Here, a plugin is being created from a directory called prompts, and the list of plugins is returning an asynchronous tags. And here, well, we have the screen prompt that this property is a question that will be displayed to the user. In this case, what do you want to know about time? It serves as a starting message or prompt. Well, here we have the handle prompt. This is a method that we pass the kernel and the user prompt. There is the method that handle use user input. Well, a kernel argument object he created contain the argument that we will pass it to the plugin. And here the main argument is the user prompt, which is what the user was written. Then the time calculator plugin is selected from a set of the plugins. Well, in this case, we have this this plugin. And finally, the invoke async method is called to execute the plugin with the provide argument, and the result is returned. Let me let's run this code. Here, let me show you the time calculator. Remember, we have the two files, the config that we set the max token, the temperature, and well, we have the description and the SKK prompt. Only we have the time plugin and the input. Perfect. Well, let me here what do you want to know about the time? For example, what day it's today? Um, Today is Wednesday, 14 August 2024. For example, another question: what day is next Friday? And next Friday from Wednesday will be 23, Friday
Yeah,
23.
that's a mistake, of course. Yes. The idea here is that you can see that LLMs on its own, they can't know information about the current date and time, but the time plugin is a native plugin from Semantic Kernel that gets the current time and date from the server or from the local machine in this case. And this information is provided as a context to the LLMs in order to prepare some answer. So when Pablito asked what day is today, this information was the combination of both the LLM, let's say, knowledge in order to answer a question or to understand the question, and the plugin, in this case, this function time, which is already built in Semantic Kernel. But of course, you can provide your own function, and we will explain that in the next demo. This part was was registered before when the kernel was being built, right? For example, here, Pablito on lines 19 and 20, he is adding two plugins: add from type time plugin, that's a native one, and add from type GitHub plugin. And GitHub plugin is Pablito's own function, own class, sorry, actually. Can you, Pablito, control
Yes.
click on GitHub plugin or open this class? As you can see, this is a class GitHub plugin. Yeah, you were correct in that one.
Okay.
And that one has different methods, such as top repositories and top repositories README. Please notice, and that's the most important part, that each of them is decorated with two elements, attributes: kernel function and description. Kernel function is important because that let's say is for semantic kernel to know that these methods could be used by the LLM in order to answer a user's question or to solve some task, some instruction from the user. You can have 10 functions, but maybe you only decorated two with kernel function. Only those two will be available or will be marked for the AI to use them. Then the description is relevant because that provides additional context to the LLM to know what is the purpose of that function, so it knows which one to use in different cases. And the same applies for every argument in the functions. You can see that, for example, the top repositories function has a handle parameter, and this handle has also the description decorator. What's the purpose of that argument? And the same goes for the next function. Those are metadata which are relevant for the AI to know when to use them if they are needed. Okay?
Yes, this is similar to the previous example, but here
with your own function.
Yes. Let me find. Yeah.
Yeah.
In this line, where the AI determines which plugin to use based on the user query. Without this line, is would not know which plugin to invoke.
Yeah.
Well, here, for example, let me test this plugin. For example, what are the top rated repositories for I need to give a user GitHub, for example, is I don't know who is.
Okay. Yes.
And let me.
So in this case, the AI has, let's say, two capabilities: information about time or information about repositories of
Mhm.
GitHub user. And in this case, there was a specific question: what are top rated repositories? And the AI determined which of both plugins to use, right? And well, here you see a result. If you navigate to my GitHub repository, which I shared a few minutes ago, well, those are the top rated repositories. By the way, in this case, it is using code. Actually, if you can very quickly go to the GitHub plugin class, you have that function, the top rated. You have your own code. That's your own implementation. That's what I mean, or what we meant when we said that connect with your own functions, right? You can see that every function has different lines of code. It can be as simple or as complex as you need, as you want, right? But those functions were invoked by semantic kernel, and you didn't have to manually, let's say, call them.
Mhm.
This is the part where the LLMs are relevant, also because of that capability, auto invoke kernel functions, right? So again, you already have your code. You only need to decorate it so it can be used by the AI, and you don't worry about building complex function calling, parameters, arguments. It is as easy as adding decorators. So it knows that the AI knows that it is available for it. Yes, so you can
Yes.
proceed with
Yes.
your example, Pablito.
Well, I only show that the all your repositories,
Yeah.
and
And you
and
can still ask
then
some other question. Mhm.
yes, and then well, my query is what time is today, and the semantic kernel understand which plugin use. Remember with this line to auto invoke kernel functions, and well, again the semantic kernel decorator, like for example kernel function and the description. This function become part of a larger framework that blends AI capability with a native application logic. Well, this is my demo.
Thank you very much, Pablito. So, well, we have some final demo. If Alexa, could you please share my screen? Thank you very much. Okay, so here we have some final demo, but just in a second, I'm going to bring it here so you can see it. Okay, so the final demo is about image generation with semantic kernel, which is kind of easy. All you need to know, first of all, is to register the Add Azure OpenAI text-to-image capability. Here you provide your model name. In this case, it's DALI 3, the endpoint, and the key that you already know. However, this, let's say, capability is still in preview, so we need to disable warning SKX0010, because, of course, if I delete this, I will receive some error. So we need to disable this warning. And also, we need to, build our kernel. Afterwards, if we want to use it, well, we get a reference to the iText-to-image service. This one also needs pragma warning disabled. Again, I will just delete this, and we will get an error there. Well, when we get the generate image async. Well, once we get the reference to this service, we can use this reference to for the method generate image async. So let's say that the image that we want to generate is this one, 3D fluffy tuxedo cat wearing tie a hat. We specify some arguments such as the size, And well, we get the image URL and we can use it as we want, right? In this case, this is console application, so we will only retrieve it, we will print it. But if we maybe are doing some mobile application, we can do some quiz about the image. Oh, yes, I see. Yeah, probably in this, yeah, this is something. Probably in the deployment that Pablito created, there is no DALI 3 model. Yeah, so I also need to because, or if you very quickly implement one, we can do this one. So sorry for that, I didn't notice. But in the meantime, I can answer a couple of questions that were in the chat. One of them is keyless authentication supported in semantic kernel from Painful Trader? And the answer is yes. When you let's say specify your methods or you register some your endpoints, you can use local ones, right? Maybe you have local hosts running on a specific port. So yes, you can do that. And the key can be empty if you don't need it. Yes. Another example would be that you set up some gateway, some backend, some API, right? Of course, there will be some rules that in the endpoint there should be method, chat completions with, let's say, resembling the same arguments. But yeah, that is also possible. Next time, I will show an example that uses,
I
let's
have
say, some, okay.
the endpoint and the key for
Yes.
another region because
Okay.
in this region I don't have ability to
No problem.
deploy DALI
Thank
free,
you.
but I share in the chat.
Okay, thank you. Sorry, Pablito. I will make you change
Oh, it's
your
okay.
keys later. Okay, let's see. So okay, yeah, I will show you some example about it, about with different local gateway, right? Okay, and what's the biggest advantage of semantic kernel versus LangChain? Is the integration with other Azure tools or option to use C#? I think bringing LangChain capabilities to C# work or for .NET developers, right? So as you can see, we got the URL and we can just test it. Let's say here. And well, yeah, this is the result of our prompt. Okay. So, well, hopefully this was an interesting topic for you. Again, we just prepared this introduction, getting started with semantic kernel. But next week we will talk about plugins. Let's say more useful stuff, building agents, about the planner, and of course memories. We will prepare some demos for you so you can see how we can implement RAG because that's the memories part, and also some unit testing, monitoring that we can use with semantic kernel. So you can see some other things that you can do besides, let's say, getting the information, like solving, let's say, more production like tasks, right? Or for some use cases that can be important for you. So before we leave, here we have some links that can be useful for you. There is, of course, the GitHub repository for semantic kernel, the documentation, and there are some started projects that you can see to get some inspiration, some ideas for your next example. So you can take a screenshot. Again, don't forget that this is recorded, so you can later pause the video because, well, we have also some other references. There is sample application, chat copilot. There is a free deeplearning.ai course where you can learn more about semantic kernel. And of course, there is also a training path from Microsoft Learn. Okay, so thank you very much for joining, Pablito. Thank you.
Well, thank you very much to the audience. Thank you, Alicia, for the behind the scenes support. And thank you, Luis, for sharing the stage again.
No problem. It's a pleasure. So looking forward to the next one, our final session. Have a nice day. Thank you, and see you.
Take care.